Hello friends, now we will see different operations on complex number, their graphical representation. Suppose complex number z is in the form of a plus ib. That will be graphically represented like this, a comma b. What's that? X coordinate is a and y coordinate is b, like this. So this is complex number z. We have to see what will be the conjugate of complex number z. Just I tell you, conjugate of a complex number is its shadow along x-axis. So it will be here. Can you guess what is the complex number a plus ib's conjugate? If you just find by means of the coordinate, it will be a comma minus b. So what is the conjugate of a complex number represented as that is a minus ib. So if I say z is equal to 3 plus 4i, what it will be? What the conjugate of the complex number will be? You will say 3 minus 4i. If I say z is equal to 5 minus 3i, what is the conjugate? You will say 5 plus 3i. So what is important thing is that you have to change the sign of the imaginary part only, not that of the real part. One more example I am taking. If z is equal to minus 3 plus 4 minus 4i, and we need to find the conjugate of that, what that will be? I saw that people say 3 plus 4i. They change the sign of the real part as well, but that not to be changed. So it will be minus 3 plus 4i. So very much clear how to find the conjugate of a complex number. The important thing, whatever complex number is given, you try to represent in the form a plus ib. Once it in that form, you can easily find the conjugate of a complex number. Now we will see modulus of a complex number represented like this. Okay, just see. This length is the modulus of complex number, and by Pythagoras theorem you can just find this value under root a square plus b square. So modulus of a complex number is square of real part plus square of imaginary part. Just one example I am taking. If z is equal to 3 plus 4i, what is its modulus? You will say under root 3 square plus 4 square. That is coming out to be 25 and 5. So if I take z is equal to 3 minus 4i, what will be its modulus? How will you write? That will be under root 3 square plus, all the time plus, imaginary part is, tell me, that is minus 4. So minus 4 square, which is coming out to be again 5. So what we saw, that modulus of a complex number and the modulus of the conjugate of the same complex number is same anyway. Now see, we need to find the argument of a complex number written as argument z. That is the theta angle which the modulus line is making with the x-axis. We can easily find tan theta. See, tan theta is equal to b by a. So theta is tan inverse b by a. So we need to find the angle anyhow. So one example I am taking. If 1 plus root 3i, a complex number is there, we need to find its argument. What's a here? You will say 1. What's b here? That is root 3. So argument, you just proceed like this. Tan theta is equal to b by a, that is root 3 by 1, which is tan 60 degree pi by 3. So what is argument of that complex number? Pi by 3. That you have to find. Just be interested in theta. Firstly try with tan theta and you will get the value of the theta easily. Z is equal to minus 3 root 2 plus 3 root 2 I. What is A? A is this thing, B is this thing. What you see, A is negative and B is positive. So where the Z is lying, X is negative, Y is positive. Where it is lying? In second quadrant. Be careful. That will be important while finding the argument, the theta. So second quadrant. Now R we can easily find. We have just developed the technique. R is modulus. So that will be A square plus B square. That will be 18 plus 18. Root 3 root 2 square, 3 square is 9, root 2 square is 2. So 18 plus 18, it is coming out to be 36. So 6. So you got the modulus, which is 6. So R is 6. Now we need to find the theta. So tan theta is equal to B by A. What technique I am telling you? You just find modulus of B minus A and then decide in which quadrant it is lying. So tan theta is 3 root 2 divided by minus 3 root 2. That is just 1. That is tan pi by 4. So theta is equal to pi by 4. So what will be argument? Just see here, argument. The theta will be actually, if it is in the first quadrant, it is okay. If it is in the second quadrant, what we need to write? That will be pi minus, instead of theta, we will just write it as alpha and then we will try to find theta. If alpha is that, we are not sure in which quadrant we find the value of alpha instead of theta here, and now we will decide what exactly the theta will be there. If it is lying in the second quadrant, it will be pi minus alpha. So it will be pi minus pi by 4. So it is coming out to be 3 pi by 4. Do you know what is happening when it is lying in the third quadrant? In third quadrant, argument is taken as, you might be remembering, this is minus of pi minus alpha. Just one example I am taking, lying in the third quadrant. What is X is negative and Y is negative. Suppose Z is equal to minus 1 minus I. So A is negative, B is negative, both negative. You will find tan theta is equal to 1. That means tan alpha is pi by is 1. So alpha is pi by 4. In that case, argument theta will be minus of pi minus alpha, minus of pi minus pi by 4. So you will get the argument. If it is lying in the fourth quadrant, what that will be? Do you know? This is just minus alpha, or you can write 2 pi minus alpha. So you just see in which quadrant alpha is lying. Accordingly, you find theta. Accordingly, you get the value of the argument. One question I am taking here. If A plus IB divided by C plus ID is equal to X plus IY, I need to prove that A square plus B square by C square plus D square is equal to X square plus Y square. So this thing is given and we need to prove A square plus B square by C square plus D square is equal to X square plus Y square. Now see, if we take conjugate to the both side of this question, this will be A minus IB here, and here C minus ID, and here it will be X minus IY. What we are doing, we are just taking the conjugate here. If a conjugate of complete thing is taken, that is equal to conjugate of the numerator divided by the conjugate of the denominator. So we did it here. So now if you just multiply this original equation with the new equation, conjugate equation, it is coming out to be A plus IB by C plus ID into A minus IB divided by c minus id, and that is equal to x plus iy into x minus iy. So what it's coming out to be? This is a plus b into a minus b form, a square minus b square, that is a square minus I square b square. I square is minus 1, so plus b square, and here it is coming out to be c square plus d square same way, and here x square minus I square y square. I square is minus 1, so plus y square. So we got the thing what we need to prove. Now very important type of problem we will solve. Value of x is given. Suppose x is equal to minus 5 plus 4i, and we need to find the value of x to the power 4 plus 9x cube plus 35x square minus x plus 4. Suppose we need to find the value of this thing. Okay, and this value of x is given, minus 5 plus 4i. What you are thinking now? Some people start thinking we will directly put the value of x here. That will be very much complex. To the power 4 is there. That will be so much tedious. So we will develop a technique. Just see how. We will just find a quadratic equation out of this. See how we are finding. X plus 5 is equal to 4i. First step you have to do, you just isolate the complex part, the imaginary part. Real part at one side and imaginary part at the other side. We have to make it real. Now we will square it. So it will come out to be x square plus 10x plus 25 is equal to 16i square. I square is minus 1. So minus 16. We got rid of I. Why we isolated I? Because on squaring it will become a real number. We know that I is a complex number, but I square is not a complex number, that is real. So we are just making it real. It is x square plus 10x plus 41 is equal to 0. That is important thing. One quadratic equation you take out of the given value. Now, whose value we need to find, you just divide that thing by the quadratic equation you got. So, we are just dividing x4 plus 9x cube plus 35x square minus x plus 4 by the thing we got x square plus 10x plus 41. So, firstly we will multiply with x square. So, it will come out x4 plus 10x cube plus 41x square. On subtraction, it is giving us, this is cancelled out, minus, this is giving us minus x cube, and here minus 6x square minus x plus 4. Now we will multiply with, you see, this is with minus x. So it will give you minus x cube, and this is coming out to be minus 10x square, and this is minus 41x. On subtraction, changing the sign, what we are getting, see, this is cancelled out. So we are just left with 4x square. This is plus 40x and plus 4. Now what we will do, we will just multiply with 4 plus 4 here. So it is coming out to be 4x square plus 40x plus 164. Now we are getting the answer. This is cancelled out and this is 160 minus 160. So if we put x is equal to minus 5 plus 4i here, the answer will be minus 160. What is the technique? You just get a quadratic equation, divide the given expression by that quadratic equation. Whatever remainder you are getting is the answer. You may ask why? How can you say that this is the answer? I'm just verifying. You see that we need to find the value of x4 plus 9x cube plus 35x square minus x plus 4. What is this here? That is dividend. And you know, dividend is equal to divisor into quotient plus remainder. So what good thing we are doing? We are making divisor 0. So this is 0 into quotient, that is 0 plus remainder, and that is minus 160. So exactly we are getting the answer whatever remainder is left over as on division of the given thing with the given quadratic equation. Very easy technique, very important technique. Once again I am revising. You just get the quadratic equation by means of just isolating the I thing, squaring, dividing the given thing with that quadratic equation, and whatever remainder is left over is going to be the answer. Hope you are understanding these many things. For the time being, okay, and bye bye.
If you like my videos, please do subscribe my channel and share my videos. Thank you.